Hello everyone and welcome to a Second Life Linden scripting language tutorial with me, John Parker, and
Me, Jack Lennon. Is that actually what it's called?
I guess so.
Oh, well, anyways. Today we are continuing with the LSL scripting tutorial. In the last video we basically did an introduction into what LSL was and giving you an idea behind what you can do with it. However, now we are going to go from the basics, work our way up until we can start getting offers and obviously going into more advanced areas of LSL scripting. And of course, do bear in mind that I am the learner, John is the teacher, me in particular being the learner, which means I'm going to be asking questions that you might be thinking, so therefore we should all hope you then benefit. Okay, John? Do you want to start?
Okay, well, today I wanted to go over the basic functions that you have in SL. Do you want me to share the screen, Jack? Sorry, I did forget about that particular snaz. Let me just double check what that's done to open broadcaster. That has been fine. Okay, brilliant. Okay, so if I click on new script and make new script and get rid of the defaults here, right. So we got a blank script, as you remember, Jack.
Yep.
Now there's one function that I love to use when it things, you know, like with the TARDIS rotor,
Yes.
making it up and down and rotate as well.
Mm-hmm.
Which is the new feature that we want to do for our TARDIS. Well, to make an object move, you have to use LL set pos.
Right.
Now, there's two functions. There's LL set pos, and there's LL set local pos. I think it's local pos. Let me just double check. Is that right? I'm hoping it's right because I can't see. I'm colorblind, and it is. No, sorry, LL set local. Rot, that was that one. So there's no local pos, it's just LL set pos. Sorry about that. No, I think to set the position for linked objects, you have to use LL set link primitive params. That nasty function that you remember from last time, Jack. Anyway, so LL set pos. Its job is simply to move the object. Okay, so if I was to, on touch start, put in a vector's something like that. You seen that before, Jack?
Yep, I've done that before.
So that's a vector, and that's x, y, and z. Now, of course, I want to move it up 1. That would be setting the z to 1, and then I think the next one. Hang on, let's just double check the what LL set pos does, because I am rubbish at remembering documentation. I've got to start learning to memorize all this. 1 sec. Okay, yeah, it literally is just setting the position. I thought there was going to be like some other variables about like so you can, I don't know what I was thinking at the time. Anyway, so if I did that, that's going to set it so when you click the object, it set it at literally 1 higher than the land. So don't click it, Jack, because that's going to make it send all the way down to the ground.
Right.
But we can counteract that. If you want to make it so that it gets to the current location and then moves it up a bit, you have to put LL get pos plus that. Okay, so we get the current position of the object, and then we plus 1 meter up. Yeah?
Okay.
Makes sense? So if I save that now. File successful. Minimize. Minimize. Now hopefully when you click that, Jack, it should go up. Okay? And if you keep clicking it, it will keep going up and up and up. By 1 meter, approximately. Okay?
Nice.
Okay then. So that's just a standard position script. Okay?
Okay. That sounds reasonably easy enough.
With the TARDIS, you would have to have it on a timer. And timers are really easy to use, and I mean like super easy. Like normally in programming, timers are a little bit more harder, but with LSL they made it quite easy. To do a timer, what you gotta do is go LL set timer event, and then in the brackets using a float, you put the amount of seconds that you want it to keep. You know, do the timer. So if every 1 second I wanted it to keep firing the timer, I put 1 in the brackets, or I could put 1.0. Doesn't matter which one. I'm going to put 1 because I'm lazy. And then you make a timer event. Now, a timer event is literally that. Timer, bracket, bracket, open squiggly brackets. Okay?
That's a new one, I haven't actually seen that one before.
No, but you're about to.
We didn't actually... Did we cover that in the last video? Or?
I told you about it, but I didn't show you it.
Nice. Okay.
Okay, so if I put the LL set pos call in here, what's going to happen now is actually, what I'm going to do, because I don't want it to keep going up without us being able to keep track of it, I'm going to make a Boolean variable that allows us to turn it on or off. So turned on, I'll put turned on, I know that's not proper English, but false. And then I'm going to wrap this around an if statement just to protect us so that we won't have it constantly flying up into the air. So turned on, if turned on, then LL set timer event naught. Naught, by the way, disables the timer.
Okay.
Else set timer event 1. So every 1 second do this, and that pushes it up. Brilliant. And then one final thing, turned on equals not turned on, which will toggle the variable. So what's going to happen now is when I click the box, it's going to check to see whether or not turned on is true. If it is true, it will turn the timer off by setting it to 0. However, if it's false, it will turn the timer on, so that every 1 second that gets called.
Right.
And then it just toggles the variable turned on. So if it's false, it sets it to true. If it's true, it sets it to false. Brilliant. So now when you click that check, wait for it. Okay. Now click it again. It stops. See?
So if I click that, it would just keep going up.
Yeah, if you'd have left it clicked, it would have just kept going up 1 meter every time. Okay?
Okay.
So you get that so far.
Yeah, that seems perfectly reasonably fine.
It's quite small, all it does is it goes up and down. So how do you think I do the TARDIS? You know, up and down, up and down, up and down. Well, it's a little bit kind of more tricky, because with the TARDIS you have to make it so it keeps going up, and then when it gets to a certain amount, it then keeps going down, then when it gets to a certain amount, it keeps going back up again. But for the simplicity's sake, I'm just going to make it go up and down. And to do that, all you got to do is do another Boolean variable called reverse. And what I mean by that is, do the reverse movement. So if it's gone up, then make it go down instead. And so what we do then is in the timer we put if reverse, and then I'll wrap the else around that next thing there. And I'll then copy and paste that there and put it, instead of putting plus, I put minus, which of course will make it go down instead of up.
Is that like increment and decrement?
Yes, but with vectors. And then I just toggle the reverse as well. Okay, so now what's going to happen is, instead of it going up and up and up and up, it should, with a bit of theory, click it, Jack, please.
There it is.
Up, down, up, down, up. And if you click it again, it should stop altogether.
Brilliant.
Yep.
Oh, hang
So
on. I
that's-
think I just clicked it again, didn't I? Or did I?
No, it seems to be.
Ah, still.
Okay, so as you can see, that is how you would do a basic up and down.
That seems perfectly fine.
Now rotations.
Yep.
Rotations are a bit more difficult because they do involve. There's 3 different. Hang on, let me just check. Yes, there's 3 different things to know about rotations, and I've never fully understood them. But I just know that I just know how to call the LL set rot function, and the LL set rot function takes a variable type of rotation. And rotation is a weird variable type because you can't really set it yourself. It's as it says on the documentation, it says the LSL rotation type is one of the several ways to represent an orientation in 3D. And unlike vectors, you can't really use them like vectors.
I don't quite get what that means.
You can't use them using those squiggly brackets. Even though you would think so, X, Y, and Z,
Right.
you can't use them. Instead, what you have to do is this. I'm going to delete all this timer stuff.
Okay, so I actually managed to do what John did, and voila. I got
Yep.
it. And there is the code to prove it. So yeah, I'll follow along and see if I can indeed catch up. Now let me just stop that so you can continue. There we go. Okay, carry on.
Okay, so rotations are very difficult in my opinion when you don't understand what the hell is going on. And trust me, I don't understand what the hell is going on when I do them. I just know that it works. I suppose I could do a lot of research. I mean, there's a huge page on rotation on the wiki, on the LSL wiki. If you want to read that up, by the way, do check out wiki.secondlife.com. It is amazing for this type of thing. Okay, so all I know that is to do rotations. First of all, you do use a vector. You use the vector to define how much you want to rotate by. Okay, so I make a vector and I say rotate amount. I don't know, something like that. And in a vector, I just put, I don't know, I want it to rotate on the z-axis 5 meters. Okay, like that. And the next thing you've got to do is normally you would think, oh, I can just use LL-set-rot on that. No, you can't. Because that's a vector and LL-set-rot requires a rotation. So we've got to find out how to get a rotation type now.
Okay.
Now, apparently, there's a little intermediate step in between doing that. You've got to make something called a Euler vector.
What's that?
Which, as it says online, another way to represent a 3D angle is using 3 numbers, which represent the amount to which the object is rotated around each axis. And if you skip to the part where it says about Eulers, apparently you need them in radians, not degrees, because those are in degrees.
Right, okay,
So we need to convert them into radians. So we make them the vector, and we call this radians. Okay? And then we use the LL, I think it's LL Euler to rot. Or am I using... No, sorry, I am wrong. I'm skipping a part. It's rotate amount, so the amount that we've got, times degree to rad. Now, degree to rad is a constant in LSL that is used to convert the values in the vector to radians amounts. So, you know, in mathematics, you can convert angles to radians and back again using a constant. I can't remember what the constant was now. That constant is that, basically.
Okay.
In fact, there you go, look, it tells you. The value is 0.0174533 and 0.0174539, which is the number of radians per degree. And that converts it for you. So there we go. You've learnt something new.
All that has just been converted then? You've just basically converted the rotate amount?
Converted it, yeah. Just by timesing it by the value.
So, you said that with the Euler bit you jumped a bit, so what's the Euler bit for?
Yes, that is considered as those are considered as Euler vectors.
Right.
Now the word Euler, I'm not quite entirely sure what it means, but apparently they just say online that it's just a way of representing a 3D angle using 3 numbers, x, y, and z.
Okay.
Okay. So the next thing is to actually get the rotation information out of that, and we do that by doing this. So I've made a rot variable here, and I'm going to call LL Euler to rot, and then in there I'm going to put the radians, like that.
Ah, so... Hang on, are you converting it again now?
Yes, so we're converting the Euler vector into a rotation variable.
Right, okay. That's not too bad.
We had to do all this for rotations, that's how I did it. And then it's LL set rot, brackets, LL get rot to get the current rotation, and I think it's times the rotation. I think it's times, I could be wrong, I'll just double check when we run this code. Okay, it's compiled, so we know that at least that works. So if I click this, hopefully... Yeah, there you go, look. The more I click it, the more it rotates by 5 degrees on Z coordinate.
I got the same result as well.
Good. And if I add an extra naught onto that 5 to see if I make a bigger change to the degrees... Yep, there you go, look, it spins around a bit when you click it. Brilliant! So there we go, that's the basic rotation. Now, there's also something else you need to know. When you use LL-GetRot is a function that returns a rotation type. But what if you want to know what the vector angles, what the angles are of the object that you've currently got?
Okay.
To do that, you've got to basically do the complete reverse of this. So underneath it, I'm going to go rotation current rotation equals LL-GetRot. So that's going to get us the current rotation of the object.
Okay. Then
I'm going to convert that to radians. So vector current radians equals LL rot to Euler. So the complete reverse. Current rotation. Okay, so that's got us the radians.
So what is this section actually doing exactly?
We're just getting the current rotation and converting it back to angles so that we can see them out in X, Y, and Z.
Okay.
Okay. And then finally, vector angles equal, or I'm going to call it current angles, equals current radians times rad to degree, like that. And that now current angles contains the angles basically, and I can prove that by using LSL to print it out to the screen for us by casting it to a string. By the way, guys, if you don't know what casting means to search it up, I can do it for you very quickly now just to show you what it, well, say what it means. If you say casting, it says, well, that's not the right word. One sec, I was just looking at the word casting for metal. There you go. A cast is a way of explicitly informing the compiler that you intend to make the conversion and that you are aware that data loss might occur. But don't worry though, there shouldn't be any data loss when you do things like this. So if I save that, and now when I click it, there you go, that's the angle that it's currently at. Click it again, the number is different. See? 50 more, which is correct.
Interesting.
What?
I did not get the same result. Why?
What's happened?
I think I've actually mistyped or misspelt something.
Double check it then.
Yes, of course I did. No worries. I know exactly what I did wrong. Just my brain got confused.
There we go. Now click it again, it should add 50 to that. Yep.
Brilliant.
Is that 50? Am I seeing that right? Yeah, it's 50, isn't it?
Yeah.
It's alright, my brain wasn't working then.
So basically, from the top, we got the rotate amount.
That we want to rotate it by.
Yeah. Then with the radians, we got the rotate amount, and then we timed it by what's that one again?
The degree to rad. Is it degree to radians?
Right.
Inversion constant.
Remind me what radians are again.
Radians are another way of representing a rotation. Again, this is a mathematical concept, but just know that you have to do it to be able to make Second Life understand 3D rotations. As by the way, Google does say a unit of measurement of angles equal to about 57.3 degrees, equivalent to the angle subtended at the centre of a circle by an arc equal in length to the radius. So there you go. If you wanted to know the definition of radius.
Also, side note, me plus maths equals.
Same, trust me, same. I'm not a mathematician, so I just know it works.
Yeah, but you're way better off than I am. Way better off in so many ways.
Trust me, I was annoyed by that. I thought it could do it automatically, but alas, no. But anyway.
Okay, so then we set the rotation to get the rotation, then time it by the.
You missed that line.
Oh, the radius.
That we convert the Euler vector to rotation variable.
And the Euler again.
Euler vector. They just call it a Euler vector. It's basically the x, y, and z in this angle brackets.
Okay, I think I get all that. Yeah.
Yep. So then we set that. We get the current one. We times it by the one that we want to set, and it should hopefully turn it around 50 degrees. And then to get the rotation back to angles, we get the current rotation, which is a rotation object. We convert it back to radians, and then we convert the radians to degrees, and then print them out to the screen.
Okay.
Okay. Yeah. Seems simple enough. I know it's a lot of weird work to get simple things like that, but trust me, you had to do that.
Now, for basics, there is one thing I really want to put in. Commenting.
Oh yes, commenting is the standard // and the /**.
Oh, so it's the same as other like PHP and JavaScript and all that.
Yep. I don't know that you can do the hash symbol though. No, you can't.
What I will say about that though, it's always good to comment your code. That way, not only for you, but if you ever do kind of show other people you're working on a group project, for example, it is always good to comment code to say what this certain function does and what it's doing. That way, it's easy to understand. In
fact, I will just quickly comment this to show people what it should look like, how commenting should be descriptive. Because some people just go, you know, that's not what you should do. You should do comments like this. So, set the rotation in angles to what we want to move. To want it to rotate by, I should say. And then the next line should be converted to radians. And the next line should be, oopsie daisy, whoopsie daisy. There we go. Next line should be convert the vector to a rotation variable, or something along that line. And then finally set it. And then of course to get it back and get the current rotation, convert the rotation variable to radians, and then finally convert the radians to angles, and then of course print it out. So it's that it doesn't have to be descriptive, but at least give it so that it's clearly understandable. Now, what I've done there is I've commented every line. Now, with programming, you don't normally do that, but I was just trying to demonstrate that you can, if you wanted to. If it's really complicated code, you can do that. Of course, I could probably shorten a lot of that by putting a whole comment block saying, this is what we're going to do. Number 1, we do this. Number 2, we do this. Number 3, we do this. Number 4, we do this. And then we do all the code after it. That's what I would probably do in a production environment, because I like to compact my comments. Otherwise, as you can see, they look quite ugly, just scattered about. But you get the picture.
That's fine.
Okay.
Now, am I right in saying that if you were to put that code in the state entry, it would automatically do it by itself without...
it would do it as soon as I saved it. So if I was to just copy that now and paste it into there and click save, as soon as I save, you should see it just move. There you go. Okay, so that happens once. Now, if I was to take that into my inventory and res it onto the ground, it will not happen again. You need to use the onRes event for that. So if I do on_res, and then there's an integer SP. I say SP, by the way, if you wonder what SP stands for, it's start param. That's used for sending messages to objects when you res them using LLRes object, just for your information. But basically, when you res an object, you want it to reset the script. And if you do that, it will call state entry every time you res the object now. So if I save that, it will do the thing again. I'll close this. I take it into my inventory. I drag it onto the ground, and as soon as I do, there you go. Calls it. Okay?
Brilliant.
That's the onRes event for you. It's only a small little thing. It's on_res, brackets, integer SP or start param, and then in there just put LL reset script to call state entry again. Okay?
That's perfectly fine with me.
Okay then. And remember, of course, anyone who's watching this can refer to the video again if they don't quite understand what I just said. And as I said, the wiki is also available for you.
Okay.
There's one more function I'd like to go by, which I think is a really cool function. Continuous rotations.
Continuous rotations.
So basically, where it constantly rotates, like smoothly. Because LL set rot will make it so that it's quite staggered. It will rotate like this, back and forth like that. But if you want to make a smooth rotation around, there's a function called LL target omega, which sounds crazy again. But if I look on the documentation, it says rotates the object or prim around axis at a rate of spin rate times LL vector maj axis in radians per second with strength gain. Now that sounds a load of gobbledygook, I know, but all I know is that is for the first part you put how much you want. You put what axis you want to rotate it by. So for example, if on the z-axis I want to rotate it by 1 meter every second, I do 0, 0, 1. Then for the second one, you put the spin rate. So I put 1.0, which basically means the maximum spin rate. And then for the gain, I put 1.0 as well, which is basically just modulates the final spin rate and disables the rotation behavior if it's 0, as it says online. So now if you click that, Jack, what does it do? Okay? It just constantly spins. Now, I have to tell you something. LL target omega is a client-only function. LL set rod, sorry, is a server-side function. Now, what I mean by that is, this rotation that you're seeing happening right now, Jack, isn't actually happening on the server. That object is not changing its rotation at all. And if I click it, see, look, it spins back.
So it does.
And then as soon as I let go, it starts moving again. That's because the client, your viewer, is rendering that as spinning, but the server isn't saving those rotations. But LL set rot does save the rotations, which is why you get a bit of a staggered movement. Okay? So now, to disable that, by the way, you have to use 0 and 0 for the spin rate and the gain. But particularly the gain, it's the gain that has to be set to 0. I like to set everything to 0 though, like that. 0, 0, 0, 0, 0, 0, 0. Now when you run that, now notice that when I save it and I let go, that's still spinning. Resetting the script does not stop that, but as soon as you click it, look, there you go, it now sets it. So it's a permanent change to the client, as in everyone who's looking at it will always see it rotating until that function is called again with 0 and 0. Okay?
Okay.
Think of it like a property. So that's a cool little function that I like to use for spinning. By the way, the higher the number you make in this vector, the faster they will move. It's per second, so 1 meter per second, or 1 degree per second, I think that was.
Okay.
Yeah, it is, I think. And that's how many radians you want to move it per second. The rate, that's the second value. I normally leave that to 1.0. Okay, so there we go. That's that then. Now, what was the other one? Was there another one?
Or is that mainly it?
Oh, yes. LL instant message is another function. If I use the LL detected key that we had last time, in our last video, to get the current avatar that clicked it. Oh, by the way, Jack, I did forget to tell you this. I've put annotations on the video from the last time. I found out that this number here and that total number here, you know when I was talking about them last time?
Yes.
I was completely wrong.
Why?
Completely. Total number is the amount of avatars it detected in the last clock cycle. The last clock cycle.
What do you mean by the clock cycle?
Well, in the CPU of a computer, the clock cycle is literally the time it takes for it to process a message. Well, at least that's how I understand it. That's not exactly true, but basically just imagine that it processes one request in a clock cycle. And now the clock cycles happen very fast, and I mean super fast. You know the gigahertz you see on your specs?
Yep.
Like 4.0 gigahertz? Well, that's the frequency of how fast the clock's moving. And it's very, very, very fast. And I mean very fast. So you know when we was constantly clicking it, we just kept getting 1?
Mm-hmm.
It's because we weren't fast enough to detect both of us at the same time in that same clock cycle.
I'll see.
We'd
Okay.
have to be going the same speed of the CPU. This variable in L detected key, however, that is the index of the avatars that it detected at the time. So if you were to hold the thing down and I was to hold the object down at the same time, and we was using the touch event, I think, not the touch start, LL detected key's number there would be the index of how many avatars there are. So there'd be 2 avatars. So if we put 0 there, it would get the first avatar. If we put 1 there, it gets the second avatar. Basically, that's what that does. But we leave it at 0 because, well, we're only using touch start and we have no need for the touch one.
Okay.
Okay, that's just a little bit of information for you guys. So anyway, LL instant message. You put the person you want to send it to, and then you put the message. So, hello, avatar. Now, when whoever clicks it will get the message. The other person won't. If you try that now, Jack.
Where am I? There we are. Okay, I got the message. Hello, avatar.
If I click it, I get a message. Okay?
Hey, here we go again.
So, LL instant message is simply to send a message to your avatar privately.
Okay.
Okay. And is there anything else that I can recall that was important for doing? Do you want to do listen events today, or like, you know, sending messages to other objects using LLC?
No, we can set this for another video.
Sure.
Yeah.
Okay, then we've been running quite long actually, so yeah. Okay, then that's about it then, really, for today anyway.
Well, I had a great lesson today. Definitely learned a lot how to manipulate the objects and their movements. So, yes, folks, next week, what I think might be best for us to do is actually start looking at the different Second Life LL functions, as we have been using them quite a lot now. And I think it'd be best if in the next video, John, we do touch on the most important ones, like the LL listener they mentioned.
LL listen, yeah.
Obviously, drop in LL say, just a quick one before we start. And obviously just the most popular ones to be used in LSL scripting.
I'll concoct a list.
Okay. Right, so then, so that's all we've got time for today. I hope you guys enjoyed. I hope you have all learnt something. I most certainly have. And until next time, we will see you very soon.
One quick thing, just before you go, guys. Please, if you haven't already, like our Facebook page, follow our Twitter, follow our Google+, if you can. And yes, subscribe if you haven't already.
And of course,
like the video if you can.
Also, we are now we now have the website up and running. It's not fully complete yet. There are still bits that need to be added. But as far as contact form and basic info, more or less that's already there. But It is currently in development, so just so you know. The website address is www.thesaturdaygeeks.co.uk, and well, yeah, that's pretty much it.
Yeah.
Also, you can, if you want to, sign up for latest news and anything that we want to post or we want to let you guys know about. You can sign up so you can get news every now and again. Don't worry, we won't spam you or anything, but every now and again. So until next time, folks, take care and see you soon. Bye bye.
Bye.
That is all we have for today, folks.
Join us again next week on another Saturday Geeks video to find out what adventure we embark on next.
Thank you for watching. Feel free to like and comment on the video below. Remember to subscribe so you can keep up to date with our latest videos.
Till next time,
Take care, stay safe, and remember,
let your geeky side
geeky
out.
side out.
Toodle pip.
Toodle pip.